Good evening, folks. So it's nice to see you all once again on our channel. We are continuing our series of streams about Cascadeur's Gods, and I'm happy to give leading role to our CTO Alexander, who will be in charge of this evening for whole hour or maybe more. Alexander, hello.
Hi guys. Okay, so let us jump in. Um, okay, so today's the part three of our streams where we study node editor, study the architecture of Cascadeur, and today we will try to create a custom constraint, and also this will be like an intro to scripting in our streams. And so I want to tell in advance that yes, this stream will contain some code. It won't be a really sophisticated code, it will be Python code. Python is the language, the scripting language for Cascadeur. But I just want you to be wary of it because, yeah, of course, reading code it might not be that simple, but without it, it's hard to create something something that can be universally used in Cascadeur. Okay, so and let's just go through the topics that we will cover today. So we'll see where the Cascadeur scripts are situated, what's the scripts in which folder. We'll understand how they load. We'll create then an empty script command, see that it appears in the command menu. Then we'll look at existing constraints, what they consist of, and like using some of that code, we will try. Using some of that knowledge, we will try to create a lookat constraint right on the spot in the scene, and then from that constraint we will create a what we call a part file, basically a template, and or sometimes it's called prefab, and then create a script to actually load that parts file and connect to objects with a lookat constraint and test it out. And before we move on, I want to cover what will be in the next streams. So, as I've already said, the ending point where we want to get, what information I want to cover with the streams is the like basically covering the scripts that we have in Cascadeur, especially rig generation scripts. So somebody potentially could try to modify the scripts, try to change the rig so it suits his own needs, and etc. And yeah, or maybe even create his own rig inside Cascadeur. So that's the end goal. But I understand that going through the scripts folder, like almost line by line, figuring out what happens here, that's probably not the most interesting thing to watch. So I'll try to mix it up with some stuff to keep you more interested. We'll see how today's stream will go. Please tell me in the chat, in the comments, was it interesting, was it okay, was it too technical? Here we will create something much smaller than the rig generation system, but it will be something that we will create almost from scratch. So yeah, that might be of some interest. And also next time, and this I think will be also one of the main things we will mix into this series of streams. We hope to make a stream where some of you will participate with me in the Discord channel, and I will answer different technical questions. We already have some questions that require a pretty long answer, and ideally they require some conversation, because it's not always obvious for me what is hard to understand, what is easy to understand. So I may be too detailed somewhere and not give enough information on the other parts where I think it's obvious, but it's actually not. So that's what we'll try next time. So if anyone wants to participate, please write in the Discord. We will write in the Discord, announce it. So yeah, I hope that we'll talk next Thursday, like in the voice chat. An example of what we will be covering are constraints and graph editor, and how to use constraints to make objects spin, basically. Yeah, so just wanted to like have an example topic that we will cover. Maybe we'll cover only this, maybe we'll cover more stuff, and we'll see in how much detail we will go. Okay, so now let's get back to the topics of this stream, and let's start with the scripts folder and how it loads. So basically, once you install Cascadeur, let me just launch the early access version of Cascadeur. I will be using I'll be using not this version but some other version of Cascadeur today. Sorry about that. It won't affect anything much, so you can pretty much like use everything we will create today and follow it, and it will work on the early access version. But I have my setup in the latest version, so I'll be using it. So about the setup, Cascadeur is installed in some folder. You can actually look at this folder here. Oh no, I'm sorry. Yeah, I won't be able to look it up here. Okay, so let me then just open the folder. Okay. So we go here. Cascadeur. So this is the folder I installed Cascadeur to. You can see the launch file here, and here there's a folder called resources, and in this folder you can see a folder that is called scripts, and that's where all the Python scripts, all the what we call parts, which are basically template scenes with template objects. That's where all of them are situated. And so you can basically open the scripts folder and change the Python code inside of it, open it as a project. What we also have is this setting ini file, and by changing this setting ini file, you can actually set a separate folder as the target scripts folder, and then the scripts will be read from that folder after you relaunch Cascadeur. And what that can be used is, for example, to set up a repository to actually change the scripts and see the changes you're making to the scripts. And and you probably want this repository folder to be not inside where the Cascadeur installs stuff, because it will then it can then, once you reinstall it or uninstall it, it will remove the files. So it's a more complicated way to track changes, but a more convenient one, at least for me. And yeah, in my case, I have this build folder, Cascadeur build folder, where our inner versions are situated. And here in resources, in settings, I have this scripts folder pointing here, which is another repository with the actual Cascadeur code. And yeah, and that's where I have my project. And I'll be using PyCharm. You can use any other how do you call it?
IDE.
IDE. Yes, so you can use any other IDE to edit the code. So yeah. Okay. Actually, we have in our documentation we have all this information about the folders and how to change the setting ini file. So I think we don't have to stop that much here. Okay. So now suppose we know here's this folder, the scripts folder, and that's where Cascadeur loads the scripts from. So how do we add a new command? And by command, let me show where commands are actually situated. So here are our commands, and all of this like creating a cube or any other of them, they're basically scripts, excluding this reload scripts and commands. So they're scripts, and they're situated in this scripts Python commands folder. And here you can see all of them. And for a script here to work, it has to. There are some conditions. Let's look at this one. Add constraint. Okay. So what are the conditions? You need the file that includes a script. It needs to have a function that is called command name, and in this function you basically name. That's the name that you will see here in the commands menu. And if you put a name and then a dot, then it will create a submenu, reconditional, and here you can see constraint points, constraint transform. And then the second thing it needs to have is this function run. And it passes you a scene, and already with the scene you can do anything you want. Actually, the scene is not that much required right now, because via the namespace CSC you can actually address the instance of the application and get the current scene, get any other scenes, create scenes, close scenes, etc. So right now the API of Cascadeur is pretty wide. I'd say it's pretty wide, because you can basically do a lot of stuff with it. You can even call, for example, for the mirror tool. You can traverse through the tools, and some of them have APIs, some don't. It doesn't include everything like totally, but most of Cascadeur has some API, and you can use it and edit, etc. Okay, so let us just create an empty script command, and then we'll see that it actually appears. Okay, create Python file, and we'll call it look at constraint. Okay. Okay. Let's add it to Git. Now, as I said, what we need to do for it to actually appear in the commands menu. Well, first we need to add a function that will be called command name. And it will return, in our case, okay, how is that submenu called? Rig additional. Dot look at constraint. That's the constraint. Okay, constraint. That's the constraint we'll be creating today. And then the second is the function called run, and we'll have a scene passed to it. And let's just use the scene to print something. Okay, of course we will print what every programmer prints. This is the hello world. Okay, maybe it's better to write like this. I don't think. Okay, so do we see it here? Well, we don't see it yet, and okay, I'll tell you the truth, although it is a sad truth, but it should appear if we press reload commands, but it doesn't appear. Okay, if we reload scripts and then reload commands, and it still doesn't appear because this is a bug, unfortunately. And it's present in the early access version. But okay, let me relaunch Cascadeur. And let's look another time, and here we see it. Look at constraint. Okay, so we press it, and what do we see? We see in the log, hello world. We can also output it as an error, and we press it, but it doesn't appear as an error. And that's because whenever Cascadeur loads, it buffers up all the Python scripts that are in the folder, because it takes pretty long time to like buffer them and get them all going. And so if we would have reloaded them for every time we press a button, it would take too much time. So you have to manually press reload scripts, and you can see it takes some time, and it says that okay, I reloaded everything. And sure, by the way, it says that in the early access version. And then when I press look at constraint, okay, we see this hello world. Now it's red because that's an error message. Okay, so we're through this. Now, to create some real constraints, let us look at the existing constraints that are there. And probably if you try to write your own code, you will have to look at the code we have already written, because yeah, we have some documentation of our API, but I think it's not enough. It's not enough detailed, and that's why we're having the streams. But it's actually rather easier to look at how we've done similar stuff, especially because it's not always that trivial how we do it. Okay, so let's open this add transform constraint and look at what we have here. And you can already see some pretty heavy code. And this is because here, if we're constraining one object to the other, you actually have to select which will be like the parent object. Okay, let's see what this script actually does. So it'll be a bit easier to understand. Let me just add a bunch of cubes. And I'll call them cube A, cube B, and cube C. And I'll just child cube B to cube A. And now whenever I move cube A, cube B also moves. And cube C is just an independent cube. And with this constraint transform, and now it asks select the parent object, and suppose I can select cube C, and that means that cube B will be controlled by cube C. And now this object is created that is called constraint cube B. And let me just show how it looks like in Node Editor. And you can see that there are different connections. Okay. So basically, this is cube C. It reads data from cube C, the constraint. It also reads data from cube B. You can see it here. And then it can write some data to cube B. And you can see that this is not active right now. And so actually, if I move cube C, cube B doesn't move. This is because to make it move, you have to activate it here. It is made mainly for interpolation. So you have to press this, constraint active on frame. It still won't work because you also have to activate it here. I'll press Shift R. That's because this is like an early alpha version of constraints. So the way you activate these constraints is you put fixation here on the timeline. That's when these constraints think that, yeah, they should be active. And so now you can actually see this in Node Editor too. Now, if I show only active connections, then, okay, a constraint doesn't try to read any data from cube B because it will write the data into cube B itself. Here it calculates constraint global position and constraint global rotation and writes them to cube B. And so if I select cube C and move it, you can see cube B is now moving too. So that's how the constraints work. Let's just look a bit inside of it. We'll create a much easier look at constraint. You can see a bunch of settings here to control when it activates and some functions that actually calculate out of the settings what happens. And okay, we can see this functions. So basically what it does, it stores a local position and local rotation, and these are local position, local rotation of cube B in the coordinate system of cube C. And when the constraint is active, then we use this local position, local rotation to calculate the real position and rotation that cube B should have. And by the way, right now I can't move cube B. So I try to move it, it holds still because it is controlled by this constraint. And when this constraint is not active, let me remove this Shift R, I remove on the timeline this dot. And yeah, it depends on this dots on the timeline, on the fixation, what is usually used in our standard rig is fixation, because we don't yet, although we are close to adding, but we don't yet have custom settings that can change over the timeline. So I just binded them to this fixation to allow users to activate them on some intervals and deactivate them on other. So, okay, so now if we go here, we can see that okay, these functions are now active. Okay, these functions are active. I'm sorry, these ones are active. And now, instead of calculating position and rotation for cube B, uh, if I change cube C or cube B, constraint just recalculates this its own local position and rotation. So when we do activate it, it will actually use this data to calculate the global position and rotation of 4 cube B. Okay, so yeah, maybe it was a pretty twisted, pretty complicated, but I hope you were able to follow through. Maybe we have some chat. No, we have some questions from chat, Ilya, because I don't have I'm not looking at the chat today. Sorry,
Yeah.
I have to update my setup finally to do it.
Uh, yeah. We have one question. It's like general question from the Highfly. Is Python worth learning for Cascadeur's extensive features outside viewport if I use Houdini as well?
Hmm. Okay, I actually didn't use Houdini that much. Um, but I think Python is pretty standard for 3D industry. So I think if you want to do technical stuff in 3D industry, Python will be okay. It will be good, a good language to start. It's more or less universal. I'm not. Some 3D packages have their own scripting languages. For example, Maya has Mel. Um, okay. So the question again is: is it worth uh, learning Python for Cascadeur if you also use Houdini?
As I understand, this question means that can user write some extensions in Cascadeur to work with to combine them with Houdini or make some transfers or something else like this.
Well, that potentially is possible. You can actually, we'll not cover it today here, but you can actually you can pin Cascadeur to call some custom scripts that you already wrote. So this way you can pin Cascadeur outside from Houdini and make Cascadeur do something. For example, from Houdini you say load this file if you have some, I don't know, custom scripts, custom buttons in Houdini that like pass the scene to Cascadeur, and you save the scene to some file, and then ping Cascadeur and make it launch a script, and it launches a script where Cascadeur loads this file, for example. Something like that is potentially possible if you're talking about like cooperation between software. And the other way around from Cascadeur, I think you can ping a program too, because like it's basically you have almost everything you have in standard Python. Adapter you can install additional packages, but like the core of Python is all present in Cascadeur, so you can use it. Okay, are there any other questions?
No, we have like idea from Discord. Uh, this girl is waiting for multiplayer Cascadeur with a linked scene. Do we have such thing in plans? It's like
I'm sorry, can you repeat it,
that
please?
he's waiting for the multiplayer Cascadeur with a linked scene. It means that connect to one workplace from different accounts and show
Hmm.
something from one account to another account.
Well, maybe in a distant future we will add it. Maybe. Also, there are things like, I don't know, Omniverse that we, if we support, that can potentially uh, can be true for some extent, although you won't be able to share control like controllers with it. Okay, so let's get back to our plan, and yeah, okay, let's look what actually this constraint command. Okay, we do understand that after we press this command, create transform constraint, this is the button we actually constraint transform. This is the button we pressed. So once we press it, this object is created and it is connected to this other two objects. But how does it know that it has to create this object? Where did this object come from? And how it got connected? And how we got this dialog message that says like select parent object. All of this actually is inside a script. So here is the script, add transform constraint, and here all this text. What it does basically is it figures out which objects are selected, if there are two objects or not, are they transforms or not. So there are some checks here, and then we have the first and the second selected object, and then we want to find out which object is the parent object. And yeah, right now in Cascadeur we don't have the order of selection of objects, because we could have selected them with a like with this rectangle selection. You can select a bunch of objects or selection groups, so we don't track which is the first, which is the second, and you have to figure out inside the script yourself. So you can ask the user, and here we actually ask the user, this dialog manager instance, show buttons, and you pass this dialog buttons that basically say what do you do if it's button 1, if it's button 2, if it's button 3. And there were 3 buttons. It was like the first button, the second button, and cancel. Okay, so there's some, not sure it's like quite obvious right now, but I think we won't jump like too, we won't go too deep into it right now. We'll just go on. I want the basic idea to be understandable, and after that we'll write our own constraint, and if we will have time we'll go there and go through all this stuff. So then we call this function bind transforms, that is not large, and we actually modify the scene, change the scene in this function, and we call this modify function. I think we'll cover it in more detail soon too, but here let's see, we call inside of it, there's different stuff happens, but we also call this function. Let's just enter this function, and in this function we will see that there's a function that basically create object by part, and that lets you create load an object that was already created and saved, and it's basically saved as a scene. So we can see that it uses this constraint separate object ortho transform into interpolation cask, and it loads an object from there, and that's actually this constraint object. And then we have to bind it, and that's what happens here. This lines basically they bind this object to other to these two objects, to the controller object and constraint object. And after we bind it, the system already basically works. And so basically we want to do the same. Let's have a really quick look at how this scene looks like. So in the scripts folder, it's the parts folder, and here, as we already saw, it's inside folder constraints, separate object constraints, and ortho transform interpolation. And we can see here is the object. It is basically a blank object. I mean, it doesn't show anything in the viewport, and it also doesn't show once you create it. And here we can see this object. It's not connected to anything, but if I show all the nodes, it has all the stuff. You can just connect it, and it will work. Well, actually, you also might have to set something up. In case of this object, you don't have to set anything up. So you just connect this object to the two objects, to the controller object and the constraint object, and it will work. And also it has this behavior part scene, and it has to point to this static data int and part type 2, have part type 2. Okay, this is just a technical implementation. I'd say a bit heavy technical implementation, but that's what you have to set in order for this scene to be treated as a parts scene, as a template scene, and to be easily created by the Cascadeur system. So now the plan is that we create a lookat constraint, like right on the spot in some scene, and then we will from that scene create a parts file, just as we have a parts file here, and then we'll write a script, mostly, to be honest, copy pasting it from the other script we just saw with this transform constraint script, and actually make it a command to create a lookat constraint. Okay, so let's go. Now also close this one. Now let's add a pair of cubes. Okay, I'll also rename them as cube A and cube B. So I'll open the node editor, and suppose I want cube A to look at cube B. Okay, I'll create a new object and call it look at constraint. And what does it have to do? So what it wants is that I want cube A to always look at cube B, and we'll use a function that will by default look with this z axis. But if we want a custom axis, we could calculate an offset. I don't think we'll have time to do that. So what do we actually, how do we actually face, look, like make one object look at another object? Well, of course we will need a vector that will that connects the two centers of these two objects. And in Cascadeur, I'll be honest, I'm not proud of it, but there is a function, although I think we should have, and we will create in future, a lookat function. But right now what we have is a function that is called rotation from positions. Okay, it actually creates this by default. What? To turn it off so it will be the same as in your Cascadeur. Okay, and what this function does, it basically is a lookat function, but it doesn't take two vectors. Instead, it takes three positions, and with these three positions, it creates a rotation that will always look at from the first position to the second position. It's actually used inside a rig for connecting point controllers to joints. So what will we need for this positions? We will need the position of cube A, and let me remember. Okay, I want cube A. Yeah, I want cube A to face cube B, so I'll move it this way. But I still need the position of cube A, and what I will output is the rotation of cube A. So, and I'll call cube A object, because that's the object we will control. And also I wanted to face into the direction of cube B, and so I'll call it target. So I have a target position, I have object position, and then I have this rotation as an output, and I will also need to rewrite this attribute in force global, because if I want to set some global rotation to an object, to a transform, I have to enforce the transform to apply the global coordinates. Otherwise, it will. Otherwise, there will be basically several functions written into one attribute, because we will try to calculate global coordinates based on local coordinates, but we will also want to write global rotation from this lookat constraint. So yeah, we'll have to enforce global coordinates to have more priority. Okay, so now here what I need is to calculate the rotation from these positions. So I can just, the object position will be the first position, the target position comes in second, and as third, I think I will be, the third position kind of lets you set the twist. You can actually, we have actually a very a camera with aim that does pretty much the same thing. So here we have this target, here we have this main position, and here we have this third, which lets you set a twist. And in our case, in our look at constraint, it will be just it will be always pointing upwards. So I'll just, but I still need to calculate it somehow. So I'll just create a sum function and add object position to an upward vector unit y. Sorry. And I will write it into a vector 3f data. And this will be the third vector, the third position I input. But it accepts position, so I had to calculate the real global position. Although if I had, of course, like a look at function instead of this rotation from positions, I would just input a vector. So now what I also need is this activity setting attribute to be active. So I'll just create a bool to be true, and I can't set it directly. This is a limitation we have, so I'll create this copy function and just copy this bool to the attribute. And I will also copy this rotation. So this rotation will go here. Okay, and I can't connect it because generates a multi-write error. So I'll just put this active here on enforce global, and now I'll be able to connect it because it will enforce calculation of local data based on global data. And we can see here that this actually changed. Okay, well, I have the look at constraint selected, and now it's facing cube A is facing cube B with this z axis, and with cube B we can now move cube B and it will be always facing it. If it moves further away, it will go up. If it moves closer, it will go down here, but you can see it's working. Okay, now how do we, of course we could do this every time we needed a look at constraint, but if we want to make it easy, for the user to create these constraints, then we will make a script, a command that will automatically add this constraint and bind it to the objects. So let's just delete these two cubes, and let's see what I have now in the node editor. the cubes are deleted. I have this look at constraint. It's connected to some default data, and all the inner part of it is still here. And now to actually turn this into a part file, I need to add this part scene behavior, create a now this is like a magical thing, so you don't have to bother, but just have to do it. And you have to set part type to, which means I import the whole object. And there are also some other options to import just a part of the object, etc. Okay, so now I want to save it. And I'll save it into this constraints folder, and I'll call it look at constraint. Okay, maybe I should just call it look at, because it already says that it's constraints. You can see by the path. Look at, maybe I can call it interpolation. I'll just call it look at, because in our case it will be active always, not only in during interpolation, it's always active. So if we connect with it, okay, the object is controlled basically by this thing, and it will always face in the direction of the other object. Okay, so let's just save it. And now let's go change the scripts. You can see here that's the new scene I created, and here you can see this is our this is currently what we have in our script. Okay, so let us just copy paste. We will just copy paste. Of course, that's not the ideal way to do it, but for now it will work for us. And then we also want to copy paste some. We can basically copy paste everything, to be honest, except this command name. Okay, let's copy paste it 100 times, and we'll really fast go through it and see what code does what. We will not use this constraint auto interpolation. Unlike here, we will copy paste all of this stuff too. And then we'll need this pretty simple function. Of course, it's better to reuse code, but for our purposes right now, it's not as important. Okay, so I just copy pasted everything. So as I've already said, this code basically just figures out that you actually have two objects selected, and they're not points, etc. So here there's some logic that basically decides when you decide which object is the parent object, and in our case it will not be the parent, it will be the target. The controller object, we'll call it the target object. So we'll ask the user select the target object, and then based on what the user selects, we call different functions, which basically just have this first and second argument swapped. Again, could be done more elegant. Can be done more elegant, I think, but never mind. This will suffice for us right now. So then we call this function bind transforms. And in this function, basically all we do is we figure out the control object, the constraint object. Oh yeah, by the way, we didn't cover in the streams the API of Cascadeur. Okay, so through this scene, we can actually get which objects were selected, and then we work with these objects. And by these objects, that's not actually the objects; it's the IDs of the objects. So they're unique identifiers. And then we come to this function, and here you can see that we have another function inside. It's a bit tricky here, but it gives good results. It's a bit of a functional approach, just a bit of functional approach. So we have this scene, and that's basically like the scene we're working with, and or the inner part of it. And then the scene has an API modify with session, and it also has some API like modify, and there you pass a command name, and this is just something that will be recorded in the log, like you're calling this function. So the name is used only there, and then it has this modify function. And so this modify function, what it does, the Cascadeur, the program, actually buffers everything you want to take, everything you want to access, to be able. So it's possible if something goes wrong to roll back, or if you run a command and then you think, okay, I didn't want to do this, and you press Ctrl+Z, and then it has to roll back. And then you can press Ctrl Y, and then it has to redo the command. So all this stuff to undo, redo, everything is done automatically. And what you have to do is you have to basically just change the scene. And to change the scene, you receive several objects here. Many of them will be this update object for us right now, which provides you with an interface that is really close to the node editor interface. And so here, what we do is we take this control object. In our case, it will be the target object. And we take our constraint object, and we find, by using the ID we figured out before, we find actually the object that basically represents a node editor object. And then we call this function, and in this function we load the template file. And in our case, the template file will be called, what is it called? Look at. So it's a real file that is situated right here. Look at. So it has to load this file, and then we come to a standpoint where this file is loaded, and we basically have these objects already, but they're not connected. So let me just comment this code, this connection code, and I'll save it. I'll go here. Okay, I'll create a new scene. Add a couple of cubes, and I will select them. Reload scripts, And now I will create a lookat constraint and suppose parent object. Let's say parent. Okay, seems like it crashed. By the way, why does it say parent if I said... Oh damn, I was changing the wrong code. Too bad for me. Okay, so this code doesn't actually compile right now. Okay, I'm sorry. Yeah, and why did it crash actually? I think it crashed because, yeah, I didn't. There were basically errors, and there's a bug right now that if you try to select something that doesn't actually exist, then it crashes. This is a bug. So let's comment out this selection too. Now I'll create a couple of cubes, select them, and select the target object. Okay, suppose it's mesh object 1. But nothing changed, but we can see that this constraint was created. And if we open node editor, we will see that this constraint is actually the constraint we created before. So it takes in object position and target position and outputs rotation, but it's not connected to anything. So how do we actually connect it? Well, the code will be pretty much the same, but let me write it from scratch so it will be more, it will be easier to understand it. So what do I have to do? I can actually even copy paste stuff from here to just not make any, lexical errors. So I want to take this mesh object 1, that will be my target, and I want to connect its position to the target position. Okay, so let me let me rename it to target, so it will be just easier to understand. So what I do is I take target, and it's pretty straightforward here. Target has an output that is called position, and I want to connect it to the constraint input that is called target position. And then I have my constraint object and its output. Position. Now I wanted to connect to constraint input object position. Okay. And then what I want also is for rotation of the constraint to be connected to this rotation of the constraint object, and active connected to enforce global. So constraint output rotation connect to constraint input. By the way, I always use like I always connect output to input, although you can do it the other way around. It's allowed, but I don't like it. I think it's easier to then read the code if it's always cited one way. Okay, and actually, for example, this enforce global, you can see that it is already connected to a constant value false. So in these cases, we have to first disconnect this input. And the same will go for these two. I want to disconnect them. And okay, I think that's it. So let's try it. I'll just delete this one, select them again, and look at constraint, target object 1, and it doesn't work because I forgot to press reload scripts. It doesn't mean it will work with this time, but it does. Okay. So now this one is working, and I can actually uncomment this line so the constraint gets selected, so you can kind of do something with it. Damn. Again, I forgot to press reload scripts. Maybe I should have a setting somewhere to just allow to do it automatically. Although sometimes we reloaded it automatically before, but it was just too slow. Okay, now I get this constraint selected, and it works. So this is basically what we wanted to do. So that's it. I will upload these files and we will place them in the description of the video. If anybody wants to grab them, put them in the folders and just try out and maybe edit them, etc. So, Ilya, do you have any questions?
Yes, and also I wanted to add that this file we also will upload into Discord in chat for streams. So, question from Drunk Beer. Can such constraint and others be integrated into character rig? Ally, look at constraint to the heads point controllers.
Potentially, yes. But those point controllers, they have different data. Different controllers have different data that they use for interpolation, etc. For the most part, you can set them up so they just use global position, and then you can constrain them as you want with the global positions. Otherwise, if you want them to use the IK data, for example, you will have to constrain the IK data on the global positions, but you will have to figure out how the points are uh, working a bit like inside, or at least at the interface part of the points to control them. But yes, that is possible, and we have um, the constraint points. They basically constraint point to some transform and control the points. And maybe we'll in the next how this constraint can work. Okay, some other questions?
Yeah, well, once more general questions about LiveLink. What about LiveLink to Unreal Engine? Is that possible or on your minds at all?
Or only what? Sorry.
Uh, is it possible or not?
Um, is it possible to create via scripts?
Uh, I suppose that in general, will we add a LiveLink to
Well,
Unreal or
I don't know. It's kind of I would answer with a basic answer that anything uh, more or less is possible. Do we plan to add it? We plan to add it, but rather long term. Uh, in the next 3 to 6 months, we are mostly concentrating on autoposing, autophysics, um, and partially on redesigning the program. So those are the main goals. But yeah, we do. I mean, we do have it on in the plans, but in the long-term plans.
Mhm. And it's also general questions closely related to previous question. Would LiveLink to Omniverse be better due to it already being linked to Unreal? Or the answer will be the same? Yeah, maybe.
Yeah, I, but I mean it's a valid question, but I'd say we didn't yet um, like investigate it and looked into it enough to easily answer this question. Um, Omniverse um, Omniverse API, as far as I know, is closely connected to universal scene description format. So if you wanna support Omniverse API, then you wanna start with supporting USD, with which means universal scene description format. Uh, so do we have that in the plans? Yes, we're gonna try that out. But uh, what will be earlier and which way we will go, we haven't decided yet, and we're like considering our options.
And question is closely related to plans. What do you mean by polishing in your Trello board?
Um, it's it basically I have this polishing thing for the release build. I mean fixing bugs, uh, polishing the standard pipeline, which will include autoposing and autophysics. I don't know, reducing settings, making things more automatic, so users need to press less buttons, etc.
Mhm. And another questions about Cascadeur Hall, I suppose. Hi, how do you manage to calculate the forces needed for rigid body to move and rotate exact to exact? to a specific targeter, for example, to align with bone transformation.
Well, we didn't do it on this stream for sure. Uh,
Yeah,
Probably
I
this
suppose
is
that.
a question about our autophysics tool. Uh,
Mhm.
to be honest, we'll have to go into some detail because uh, like there are different parts of the autophysics tool. Uh, they do different things. Uh, One example is that when solving the equations for the parts where the character flies in midair, for example, um, we optimize the uh, like the angular velocity at the start of the jump, and to make the character land in the rotation that it had in the original user animation. So it will rotate according to physics, and it will end in the uh, rotation and position that the user wants. And to do that, we're solving some equations mathematically. Um, so how do we do it? Well, mostly by solving equations. And
Mhm. I will write down these questions and not forget about this. So I suppose that's all with questions because of while you were answering, there was no new questions, and yeah, I suppose that we can say goodbye to our guests.
yeah, as always, thank you. I also have a question. What do you think about the streams? Should we continue them? What is more interesting? What is less interesting? I would really like to adjust. I see there are a lot of general questions. I think that although the streams are not dedicated to general questions, it's still fine to ask them, and I'll be happy to answer them. Uh, yeah, and maybe if you wanna ask some more of the general questions, you can come to the stream that we will make next time, which will I will be streaming, but we will be also talking via Discord, and I will but yeah, I will stream what you are saying also via the Discord, and yeah, and so we can talk about more general stuff, like uh, by in a way where we will have more ability to interact, more with each other.
Yeah, I suppose that it will be a very good experiment to connect with our community, and I hope that there will be a lot of guys or uh, old friends and other guys and, and new friends.
Okay.
So,
Yeah.
bye bye, folks. See you next time.
Bye. Thank you. Thank you for
Thanks.
coming.